Hello friends, we want to continue with our studies on trigonometry, and today we are moving on to trigonometry 13. So we will be acquainting ourselves with other things that are very important. So we want to look at the trigonometric identities. And so here what we are saying is that we want to look at the relationship that exists between sine, cosine, and then the tangent. Now, if you look at the diagram, we see that this line is movable. It can move. We can put it here and then stretch it this way until we get to 360. So from 0, we get to 90, 180, 270, and then 0. Then you can also get any other angle. Now with this one, we can also get a right-angled triangle with the length here being y and that being x, and this is the hypotenuse. And so based on that, we can get sine theta, which is opposite over OP, which is the hypotenuse. Cos theta is the adjacent, and then over the hypotenuse. And then our tan theta, that's also opposite over adjacent. Now, there's something that we can also take note here. If we normally find the sine theta over cos theta using the right-hand side, then we'll come to y on x, which gives us tan theta. So it is obvious that tan theta can be written as sine theta over cos theta. So we need to take note of that. Now, we want to move on to the Pythagoras theorem. When we look at this right-angled triangle, we can get it in any of the quadrants. So you are seeing that for any position, we can get that right-angled triangle. And for that, we say that our x squared plus our y squared will be equal to our OP squared. And so we get this expression. So this is very important expression that we'll be using to derive some identities. Now, what we are going to do is that we are going to divide through by OP squared, and then we shall also divide through by x squared, we shall also divide through by y squared, and that will give us the identities that we are actually looking for. So look at it carefully. This is very important when we derive it from this right-angled triangle. This length is the x, this is the y, and that is the hypotenuse or the OP. Then when we square x and y and find their sum, that will give us OP squared. Now, so dividing through, as I said earlier on the previous slides, we divide through by OP squared. So we get this, divide OP squared, then we used to have the OP squared here, so we divided by OP squared to give us 1. So that's first. Now we go back to that expression and divide also through by x squared. So that also gives us this expression. Then finally we divide by y squared, and that gives us this expression. So look at it carefully. 1, 2, 3. Look at it carefully. We pick the x squared plus y squared equals OP squared and divided through in terms by OP squared, x squared, and y squared. Right. So 1 becomes cos theta squared plus sine theta squared equals 1. Then 1 plus tan theta squared equals sec squared theta. And then cot theta squared plus 1 giving us cosec theta squared. Now, we can look at this and say that we can rewrite this in this way. Now, for us to avoid the usage of the bracket, we can write it as cos squared theta plus sine squared theta giving us 1. Then 1 plus tan squared theta giving us sec squared theta. Then cot squared theta plus 1 giving us sec squared theta. So these three identities are very important. And we'll be using them. Sometimes we make sine squared theta just the subject, and again we get 1 minus cos squared theta. Or make cos squared theta the subject and get 1 minus sine squared theta and use them. Sometimes we make tan squared theta the subject and get sine squared theta minus 1. And vice versa. We'll do same for cot squared theta plus 1 giving us this. So sometimes we can make this the subject and say cot squared theta is equal to cosec squared theta minus 1. And so we'll be varying the usage in that form. So take note of these identities. We'll be calling them and using them at where they'll be relevant. Now I want to solve some equations. So we are saying that solve the following equations for angles in the range theta between 180 degrees, that's negative 180 degrees and positive 180 degrees inclusive. Right, so let's look at the first question. So we want to solve the sec squared theta plus tan squared theta equals 6. So what we're going to do is that we are going to write all this in terms of one ratio. So we are going to convert sec squared theta to tan. And remember that one of the identities tells us that 1 plus tan squared theta is sec squared. So in place of sec squared theta, put 1 plus tan squared theta there, plus our tan squared theta equals 6. Now this is 1 tan squared theta plus 1 tan squared theta. So we get 2 tan squared theta. We subtract 1 from the left-hand side, we subtract 1 from the right-hand side, so we get 2 tan squared theta equals 5. Let's divide both sides by 2, so we get tan theta equals 2.5, and then we find the square root, so we get 2.5 under the square root sign. That will be plus or minus. And then the value for the square root to give us plus or minus 1.581. Now, tan inverse of this value plus or minus give us plus or minus 57.7. Now, with this one, when we go to the normal Cartesian plane that we use in finding the values, we can see that with this in the first quadrant, we can also get this in the second quadrant by getting this as the acute angle. And then what we do is that we subtract it, so together we get 122.3 degrees. You can see that when you add them, that takes you to 180 degrees. So that's how we do that. So this will be the answer for this section. Now, the next one is that we actually want to solve 4 cos squared theta plus 5 sin theta equals 3. So in place of cos squared theta, we shall put 1 minus sin squared theta there, and then we have the expressions. So 4 times brackets open 1 minus sin squared theta brackets close. This is actually 4 cos squared theta from the first identity that we actually derived. So we clear the brackets. 4 times this gives us that, 4 times that gives us this. Then we have our values here. So let us rearrange them. So this comes first, this comes second. And then what we are going to do is that we are subtracting 3 from 4. That will give us 1. So we put it here. Subtract 3 from the right-hand side, we get 0. Now we have rearranged them. Let's multiply through by -1. So we get 4 sin squared theta minus 5 sin theta minus 1. Now this is a quadratic in sin theta. This is a quadratic in sin theta. And since finding the factors is not easily accessible now, what we'll do is that we'll resort to the quadratic equation formula that we normally have. So we are saying that sin theta will be equal to negative, into brackets, -5 plus or minus square root 25 plus 16. Remember that this is A, the general quadratic, gives us A, B, and then C. So that's what we are using here. So the formula is -B plus or minus B squared minus 4AC. And so that's what we have used under this. So minus 5 plus or minus our B squared. B is -5. So -5 times -5 gives us 25. And then our 4 times 4 and then times -1. So we get 4 times 4 times -1. That gives us positive 16. So when we simplify that, negative gives us positive. So plus or minus this one we add, we get 41. So we come to this side, and square root of this is 6.403, and then our 5. So we split them plus, and then we take the negative as well. Now 5 plus 6.403 over 8, the whole of this will give us something more than 1. And remember that our sign has values between 1 and -1. 1 and -1 inclusive. So this over that value. So move on to this one. We have 5 minus 6.403 over 8. And when we solve that, we will get this value, and that will be -0.1754. So sine inverse of that will give us -10.1. And remember this, that we can also move the clockwise way, and then we shall still get this value as well. So -169.9. So let's look at that carefully. So these are the values that we'll actually get. So the third question is that we are going to solve cot squared theta being equal to cosec theta. So we all remember that cot is 1 over tan. So we have cos squared theta over sine squared theta. And then this is 1 over sine theta. So we multiply both sides, cross multiplication. So what we are going to do is that when we bring the sine squared here, this will divide 1, so we get sine theta. So that's why we have this. Now, in place of cos squared theta, we are putting 1 minus sine squared theta there from the first identity, which is cos squared theta plus sine squared theta gives us 1. So we push or we subtract the sine squared theta from both sides, so that gives us this one. Now, from here, we are going to rearrange. So when we do that, we subtract sine theta from both sides. That takes us, finally, we actually multiply through by our negative, and that gives us sine squared theta plus sine theta minus 1. Over here too, there's a quadratic in sine theta. So we use the quadratic formula to find our sine theta. So our A is 1, our B is 1, and then our C is negative 1. So using that, we get this expression. So our sine theta, splitting it, our plus will be here, and then our minus will be there. The whole of this gives us positive 0.618. This will give us negative 3.236. So that will not be in the range for sine theta. So we find the sine inverse of this, and we get 38.2 degrees. And then we can move on to the second quadrant and get 141.8 degrees. So that is how we solve this type. So we can look through and see how we normally deal with that. The fourth question is tan theta plus cot theta is equal to 2. So tan theta will stay, but cot is 1 over tan theta. So we've been able to convert all of them into tan theta. Now let's multiply through by tan theta. So tan theta times tan theta gives us tan squared theta. 1 over tan theta times tan theta will give us 1. Then 2 times tan theta will give us 2 tan theta. So we get this. Let's rearrange them. So tan squared theta will come. Let's subtract 2 tan theta from both sides. So we get negative 2 tan theta plus our 1. Now for this one, we can do the factorization. 1 times 1 gives us 1. And then normally we can say that for us to get this negative 2, then we can make it negative 1 tan theta times negative 1 tan theta. So that gives us a positive tan squared theta. All right, so when we split, we get negative tan theta, negative tan theta. So we can do this factorization because we have the 4 terms. So we now seen that tan is common here, tan is common there. So you can get tan theta into brackets, tan theta minus 1. Over here, negative 1 is common, so negative 1 out to get tan theta minus 1. Now this and that are common factors, so get tan theta minus 1 in the bracket, and then tan theta minus 1, so repeated. So we are saying that tan theta is equal to 1 or tan theta is equal to 1 repeated. Now, tan inverse of theta is 45 degrees. And because we're given the range to be negative 180 to positive 180, then this one, we can use the clockwise manner also to find this as negative 135. So these are the values that we can get within the ranges that were stipulated. Great, so you can look through it again. Take your time. Look at the steps, self-explanatory steps. Fantastic. Let's move on. Now, I want to find the general solutions of the following equations. So let's look at how we can also do that as well. Take your time, follow the lessons, and follow the lecture or the teaching patiently. So we have 4 cot squared theta plus 12 cosec squared theta plus 1. So cot squared theta can be written as cos squared theta over sine squared theta. Cosec theta can be written as 1 over sine theta, so 12 over sine theta plus 1. What we are going to do is that we are going to multiply each of these terms by sine squared theta. So when we multiply by sine squared theta, we shall obtain these values. And so what happens is that 12 over sine theta plus 1, so we get 4 cos squared theta plus 12 sine squared theta plus sine squared theta minus 1 equals 0. So we put, in place of this, we are going to put 1 minus sine squared theta plus 12 sine theta plus sine squared theta equals 0. So we clear this bracket, and when we do that, we get 4 minus 4 sine theta squared theta plus 12 sine theta plus sine squared theta equals 0. Minus 3 sine squared theta plus 12 sine theta plus 4. It means that we have rearranged this side. We have rearranged this side. And then we have minus 4 sine squared theta, then 1 sine squared theta. So that reduces to be 3 sine squared theta. Then our 4, let's bring it over here. And then our 12, let's bring it there. So we multiply through by negative 1, and then that takes us here. So we have our quadratic in sine theta. And so we look at this, you could see that the factors are not easily accessible. So what we do is that we resort to the quadratic formula. So sine theta will be negative 12 plus or minus square root of 144 plus 48 plus 6. So 12 plus or minus square root 192 over 6. So we get this, and this is small than 1. So we'll not be using this one. But when we come here and we compute this, we shall get negative 0.31. So we can find this value. So sine theta will be 18, negative 18. So the general solution in terms of radians will be 2n pi plus negative 18 degrees, or theta will be 2n plus 1, the brackets pi plus 18 degrees. So we can simplify them and get 360 n degrees minus 18 for this one. And then for that one, we can get 360 n degrees plus 190. So look at it carefully. Take your time and go through, and you see that you can easily understand that. We are moving on to 4 sec squared theta plus 3 tan theta being equal to 5. That is 4 sec squared theta minus 3 tan theta equals 5. So in place of sec squared theta, we are putting tan squared theta plus 1. And then we do that. So let's clear the brackets. 4 times this gives us that. 4 times 1 gives us that. Now at this point, let us rearrange. So our 4 tan squared theta comes, and then minus 3 tan theta. And then we subtract this 5 from both sides, so that takes it there. And then the next step, that because we have this 4, that also subtracting and get minus 1. So we get 4 tan squared theta minus 3 tan theta minus 1. This is a quadratic in tan theta. This one we can look at it. 4 times negative 1 gives us 4, and then we can find 2 factors that will multiply to give us a value, and then when we add, we get negative 3. So that will be negative 4 and then positive 1. So we can split this, and then we get this. Okay, so from this tan is common, so we can bring 4 tan out, or 4 here, 4 there. Then we get tan theta minus 1. Then over here 2, 1 is common, so we bring the 1 out. So this and that are common factors. So we shall get tan theta minus 1, and then 4 tan theta plus 1. So either this is equal to 0 or that is equal to 0, and so that's what we have over here. So making tan theta the subject, to get negative 1 over 4, or tan theta is equal to 1. So over here, tan inverse of theta for this will give us negative 14 degrees. Then tan inverse of theta will give us 45 degrees. So from here, we can now write our general solution. We have learned this already, how we write the general solution. So right away, we have theta equals 45 degrees plus 180 degrees. And then theta equals negative 14 degrees plus 180 degrees. So let's look at it carefully. Remember how to write the general solution for tan. Fantastic. Great. So we want to look at 2 cos theta minus 4 sine squared theta plus 2. Okay. So right away, we want to do that being equal to the value that we have over here. So straight away, in place of sine squared theta, we are going to put 1 minus cos squared theta. Then we clear this bracket. So that takes us to the next step. So 2 cos theta, 4 times 1, 4, then negative 4 times this gives us positive 4 cos squared theta plus 2. So we have everything in terms of cos. So we rearrange. So 4 cos squared theta comes, and then 2 cos theta comes. And then this minus 4 plus 2. So that reduces to negative 2. Then we can divide through by 2. So that takes us to this point. Divide through by 2. So this 4 divided by 2 gives us that. This 2 divided by 2 gives us 1. This 2 divided by that gives us 1. Now from here, we can now do the factorization. So 2 times negative 1 gives us 2. So you can get positive 2 times negative 1 giving us negative, that is positive. Then so the values then giving us the positive 1 here. Because 2 times negative 1, when we add 2 and negative 1, we get 1. So we can now split this one and do it in such a way that we'll be able to do the factorization. So 2 cos theta minus cos theta also gives us 1 cos theta. So cos is common here and 2 is common there, so we can do the factorization. 2 cos theta to cos theta plus 1, and then minus cos theta plus 1. So we can do the factorization. This is common, that is common, so that comes out, and then 2 cos theta minus 1. So we get this. Now either this expression is equal to 0 or that expression is equal to 0, and that's what we have over here. So cos theta is half or cos theta is negative 1. So for this, the cos inverse of half will give us 60, then cos inverse of this will give us negative 180. So for this one, we'll use the cos relation normally to get the general solution to do that. And then for this one, if you go to where we normally have the quadrants, you will see that this will be multiples of 180 degrees, because either clockwise or anti-clockwise will still come here positive or negative. So this will just be the, what we are going to do is that we just find the multiples of this and that gives us the value. So let's look at it. So the general solution is 360 n degrees plus or minus 60 degrees. But when we come here, 2n plus 1 brackets open and close times 180 degrees. So when n is 0, we get our 180. And then we'll move on and on and on. Yes. So that's great. We want to prove some identities. So let's see how we do that. First, for theta plus tan theta will give us sec theta, cosec theta. So you can pick any of them. You can prove the left-hand side to get the right-hand side, or you can prove the right-hand side to get the left-hand side. So you just look at them carefully by inspection and see which one to start. So we want to start from here. So cot theta plus tan theta, we can write this as cos theta over sin theta. We can write this as sin theta over cos theta. Then we get the common denominator. And remember that this divides that, so you get this times that. Tells this will divide, so we'll get this times that, we'll get this. So this one will give us 1. So you get 1 over cos theta sin theta. Remember that 1 over cos theta is sec, 1 over sin theta is cosec. So we have done it. So that's how we go through it. So look at it carefully. Look at it carefully. That's fantastic. So you can also look at this one and say that you want to prove it from this to that. All that you do is that you write it as 1 over your cos theta sin theta. Then you move on and come back and then you simplify to get this one. So you can always do it whichever way that you want it. Now the second one is that tan square theta plus cos square theta is equal to sec square theta plus cosec square theta. So we want to use the side to get the side. So what we are going to do is that tan square theta is sec square theta minus 1. Remember that we have the identity that says 1 plus tan square theta is sec square theta. So we just make this the subject that gives you this. The same vein, we also have 1 plus cos square theta giving us cosec square theta. So we make this a subject and get that. Now, once we get here, we combine a negative 1, we get this, and that gives us the right-hand side. Now, you can also be using this side also to get that. So you start with sec square theta plus cosec square theta minus 2, and then you split this. So you make this minus 1 here, minus 1 there. Remember that this will give you the tan squared, and this minus 1 will give you the cot squared, and then that brings you there. So whichever way, you can still do that and get the answers. We want to move on to the next question. Sec squared A giving us cosec A all over cosec A minus sin A. So we want to start with the side. So you write sec squared A will give us 1 over cos squared A from here. Now let's convert this into sine. So we get 1 minus sine squared A. Let's try and introduce cosec A on top and then the denominator as well. So this times 1 will give us cosec A, and then the denominator times cosec A. Let's expand the bracket. So we get this. Now over here, what we are going to do is that the whole of this will leave it, and then this one will give us 1 over sine. So we write it here. So sine squared over sine A, all the others are intact. And remember that this will take one of this out. So we get, that takes us back. So that is how we move from this side to that side. You can also move from here and then move upwards. So you get to this point, you try to rewrite this one in such a way that you get this, then move on that way. So whichever way that you want to use, you get the values. Let's now move on to this expression. We want to show that this is equal to this one. So you see that we have the square here, and this, we can treat this as a binomial. So pick this as 1 and then pick this also as 1. So that's what we have done over here. So using the normal binomial expansion for squares, so we square 1, we get 1, and then 1 times this times 2 gives us 2 sin theta cos theta. The next step is that we are going to square this. So when you square this, you get sine squared theta, and then plus 2 sin theta cos theta. And then what we are going to do is that we'll square this, so we get 4 squared theta. So let's do the rearrangement. Let's expand this. So that takes us to this. So we have the whole of that. Now we are going to do our rearrangement. So we have 1 plus 1 that will give us 2. We have this expression, and so we also have that, we have this. So the next step is that this 2 is common. So let's bring that out. We'll get that in the bracket. So we got 1 plus sine theta plus cos theta plus sine theta cos theta. Now over here, we will see that 1 plus sine theta. And then when we come here to see that the sine theta is common to this, and then the cos theta is common to this and that. So let's try and bring the cos theta out. Let's factorize that. So that takes us to cos theta into brackets 1 plus sine theta, and this one is already there. So this is a factor, and that is a factor. So this common factor, that common factor, we bring that out. So we get 1 plus sine theta, and then we get our 1 plus cos theta as well, and that takes us on. So we get it this way. So that takes us back to the expression that was given. So that's how we actually do that. It's long, but if you take your time patiently, you will be able to understand. Thank you so very much for giving me your attention. Have a blessed day. Bye for now.